Alright, so today we're going to be doing a lecture on phase diagrams. Alright, so phase diagrams are similar to phase changes, but they're just the diagrams themselves. Alright, so what it is it's comparing pressure versus temperature. Alright, so they always put pressure on the y-axis and temperature on the x-axis. Alright, so increasing pressure, increasing temperature, like usual. So what it is showing is that there's three different phases. Alright. And so there's a solid, there's a liquid, and there's a gas. So depending on whether or not you change the temperature or you change the pressure, how will that change the phases? Okay, so pretty basic stuff, but there's two things that we need to keep track of. Okay, so there's 2 points right here. One right here, and this one's called the triple point, and this one's called the critical point. Alright. So what are the triple point and what are the critical point? Well, the triple point is just when there's equilibrium between solid, liquid, and gas. So it's converting between solid, liquid, and gas in equilibrium. So that's the pressure and temperature that would occur. Okay? Critical point's a little bit different. Okay? So critical point is when there's the liquid and the vapor have the same density. Alright, so they have the same density, so you can't tell whether or not you're in the liquid or you're in the gas phase. So it's indistinguishable. So it's not an equilibrium, but it's just indistinguishable between liquid and gas. Alright, so what happens with the critical point is when you go past the critical point, so everything to the right of it, this is going to be called a supercritical fluid. Alright, so everything past this will be a supercritical fluid, and that's when the liquid and the gas have the same density, meaning that you can't tell the difference. Alright, so those are important points that we need to keep track of. Alright, so just I guess a very simple thing would be saying if you are at a certain pressure, or let's say you're at a pressure of, let's say, 50 atmospheres, and you went from, let's say, negative 10 degrees Celsius all the way up to 30 degrees Celsius. Okay, what would the phase change be? Well, all we do is we find 50 atmosphere at negative 10 degrees Celsius, and then now we're saying that we keep a constant pressure, and now we change the temperature. Alright, so we went from solid to gas. Okay, pretty simple. Okay, so there's one thing that we have to keep track of, and this is kind of the uniqueness to water. Alright, so water is different in the fact that water, the density of a solid, so density of the ice, the solid state of water, is going to be less than the density of the liquid, and this is specific for water. Alright, so what does that mean? So that means that this is going to change the phase diagram. We don't need to know why it changes, we just have to be aware of this fact. Okay, so we know that this is H2O, and this is the phase diagram for most other compounds, and we're just going to use the example N2 and many others. So I'll put a dot dot dot. So what we need to know is that water is specific in that the solid to liquid, is more directly to a negative slope versus the nitrogen is going to be slope more to a positive slope. So what are the implications to that? Well, it shows that we can go, in water's case, we go from a gas to a solid to a liquid if the temperature is held constant. So we can go straight from gas into solid into liquid. Can we do that here? And the answer is no. We can't go from gas to solid and then to liquid all in the same temperature. Right? We can go gas to liquid to solid in the same temperature, but that's different. So if they ever ask you which state or which compound can change from gas to solid to liquid, we know that it's water. So we just have to keep track that water is sloped a little differently between solid and liquid phase, and that's due to the density difference.